Hi guys, welcome back to the channel. I hope you all are doing good. So let us do problems on LeetCode. I will get back to the dynamic programming problems. I just wanted to do some different thing, we have been solving some kind of the similar kind of problems, right? So we can get some better variety now or different topic just to challenge ourselves. So share this video, like the video, and subscribe to the channel. I'm telling now only, and just share it so that you can challenge your friends also, or maybe they can learn. So let us see today's problem. What is today's problem? It is called minimum limit of balls in a bag. You are given an integer array which where the ith bag contains nums I balls. Okay, and you're given an integer max operations. You can perform the following operation at most max operation times. Take any bag and divide it into two new bags with positive number of balls. For example, a bag of 5 balls can become two new bags of 1 and 4 or 2 or 3. So they are saying you just divide it in such a way that each bag contains positive number of balls, which means one bag cannot contain 0 balls, which is obvious, right? Why would you divide it into two bags in such a way that one bag won't even have a ball? Okay, so let us read further. Your penalty is the maximum number of balls in a bag. You want to minimize the penalty. Return the minimum possible penalty after performing the operations. Okay, so let's just have a look at the time complexity of the problem. Actually, we can't decide like that. So let us look at the constraints. So 10 power 5 is the max. So time complexity directly you can't decide. After looking at constraints only, one should. I mean, if the problem is so trivial that you already know it, then fine, yeah. So, okay, so number of bags, the n value can be at most 10 power 5. Whenever the constraint is like 10 power 5 or something, always sometimes, I mean, not, yeah, always you should think about an n log n solution. Most likely n log n solution will work. I'm not saying this will work everywhere, but most likely, most of the time it does work, n log n solution. So for n log n solution, usually binary search will be applied. So this is one way of trying to get to know that, okay, fine, we can think of applying binary search concept. But actually, how do we justify that, okay, we can do binary search? So see, for binary search, what do we need? So for binary search, we need a search space. And more importantly, we need to know if it is like monotonically increasing or decreasing, right? Like if they're asking a minimum or maximum or something like that, like minimize or maximize. So then we can think about binary search. So in this problem, what is there? We are given some n number of bags. Correct. So some n number of bags are there. Each bag has some number of balls. Now, what the problem says over here, penalty is the maximum number of balls in a bag, and we want to minimize penalty, which means suppose this one of the bag has 100 balls. So suppose the array is like this, okay? Suppose the array is like this. So this represents 5 bags are there, and each bag how many ever balls. So without applying any operation, the penalty over here will be 100 because 100 is max, right? But what the problem is saying, what you can do is you can split this bag in such a way that each of the two bags when you make should contain positive number of balls. Suppose I put 50 and 50. Now you see what has happened. Instead of 100, the answer will be 50. Suppose I'm allowed one more operation, then 25, 25. So now they're saying number of operations are fixed. That means you can do at most that many only. You can do at most that many. Obviously, you would want to do more and more operations. If you observe the problem, see, because the number of balls will keep on reducing in each bag. As and when you keep dividing, the number of balls will decrease. So it was 100, it became 50, here it became 25, correct? So your penalty, the chances of your penalty also decreasing will increase, right? So you want to what? What is the ultimate goal? Ultimate goal is minimize the penalty. So somewhere minimize we got. So we can think about using binary search. Somewhere we got that idea, right? How to think about binary search? First of all, we need to know what is search space. What are we searching for here? Here we are searching for penalty. The answer is what? Penalty. So we are searching for minimum penalty. But actually, are we searching for that, or like can we conclude that we only go with penalty? What are the two things here? See, we can't directly say that our search space is the penalty. We can take penalty as like answer, of course, but our search space will be something like what is the maximum number of balls in a bag, which is basically penalty only, right? So actually our thought process should be in this way, that we should be focusing on what is the maximum number of balls we can keep in a bag in such a way that after dividing the bags into some more bags, the number of operations taken to do that will not exceed our max operation. So I'll repeat that. Here what we should do is, our search space will be the number of balls in a bag. That will be our search space, not even maximum number of balls. So if we are refining our thinking, what are we understanding? That our search space should be what? Balls in a bag. How many balls can we keep in a bag? Which means what? If we have to apply some number of operations, can we reduce the number of balls in a bag so that we will get a smaller penalty? And how many times we reduce, it should not exceed beyond maximum operation. That means we should not do more number of operations, but we should reduce the number of balls in a bag so as to get a minimum penalty. So let us take an example here. What I'm trying to say, I will tell you. So suppose the array is something like this. I think we can take this example. 2, 4, yeah, something like this. So what will be our search space? So search space, whenever we consider, we say lower limit, upper limit. Now you tell me one thing, what is the most desirable thing? That lower limit is 1. Why? We want that each bag has only one ball. That will be the best possible answer, correct? Because then our penalty will be 1 only. And what is our higher limit here? Higher limit shall be the maximum number of balls present in any bag. In this case, 8. See, actually, higher limit you can take anything. You can take 10 power 9 also, it doesn't matter. But logically speaking, the maximum number of balls you can have in a bag cannot exceed the number of like in the original array, the maximum number of balls in a bag, it can't exceed that. Your search space higher limit value can't exceed that, right? So we have found our search space. What is our search space? L will be equal to 1 and H will be equal to max element of the balls, number of balls in the bags. This is the input, right? We're talking about input, given input to us. So first we have fixed the search space. Now what should we search for? So in binary search, what do we do actually? In binary search, I'll just decrease myself a little bit. Yeah. So in binary search, we do something like this, right? Mid is equal to L plus H minus L by 2. What is this? So we are trying to, so after we create a search space, we are trying to see that, okay, if this mid value will satisfy some condition, if it will satisfy some condition, should I check on the left side or should I check on the right side? That is what we do, right? So what we do, we find mid first, and then we'll write some function. So I'm just telling you the flow of the coding part also. So what we will do is we will find mid, we'll write some function and check for some condition. In this case, we'll discuss what that condition is. But after we find the condition, if it is possible, we have to decide which side to go. Should we check on the left side or should we check on right side? Left side, when do we check? When we want to minimize our answer. Right side, we will check if we want to maximize. In this case, what is it? We want minimum penalty. So we want to minimize, correct? So what we'll do, we will check on left side. So what does it mean check on left side? We will make h equal to mid minus 1. And if our condition is false, if our given condition, that condition we will write, that function we will write. So if it is false, we will go on the right side, correct? So okay, this much we know now. Okay, so what will be mid now? So what is our search space? What is our search space representing? The number of balls we desire to have. That means we are saying that, can I perform some number of operations which does not exceed our max operations in such a way that each bag has at most mid number of balls. So mid over here will represent number of balls, at most that much, at maximum that much number of balls I can have in the bag. So is it possible? What does it mean, is it possible? Can I divide the bags in such a way that after dividing, the number of operations should not exceed our max operations? That is one condition. And if this is also, first of all, this should be satisfied. If this is satisfied, then we should check if each and every, if it is possible, basically, if it is possible to divide such a, the bags don't contain more than this number of balls. So if this condition is true, if we are able to do it in max operations within this, then we will check on the left side to get a minimum answer. And every time we will record our answer. That means every time we'll keep a variable answer equal to mid. But when will we do this? When we find out that when we write this function is there where we are checking for if we do the number of operations in such a way that each bag will have at most mid balls, that number of operations should not exceed max operation. Then we will record mid and check on left side. Otherwise, check on right side. So in this example also, I will show you what will happen. I'll show you the working. Okay. So initially L is equal to 1, H is equal to 8. What is mid? Mid is equal to 4. And over here, what is max operation? Max operation is 4. So given this is input. So input is max operation 4. Now mid is equal to 4, which means, can I do some number of operations such that maximum number of balls in a bag will become 4 only? So see, this is already 2. I don't have to worry about this. This is 4, fine. This is 4, fine. But this is 8. So 8 I can split in how many operations do I need? If I split 8 like 4, 4, correct? Then it will be satisfied, right? So I need only one operation for this. How to calculate for each bag how many operations you need? That is simple. So number of balls is there, divide by desired number of balls, and take the floor value. So this is because if it's an odd number, I mean, it's not visible exactly. So for in this example, what we'll do, 8 minus 1 by 4 and floor value, which is equal to 1. So I think I told wrong. It's not about odd number, because we just want to know how many operations to be done. And how will we get to know? We will get to know by doing this: number of balls minus 1 divided by desired number of balls. So actually this is the formula. Forget whatever I told, floor value, that is not meaningful. Number of balls minus 1 divided by desired number of balls, like I showed in this example, correct? So it will be 8 minus 1 by 4, which is 1, which means what? This bag which contains 8 balls, if I want to split it into bags such that each bag contains 4 balls at most, I need only one operation. And how to find for other examples? As I told, number of balls minus 1 divided by desired number of balls. So basically, if array is suppose ball of I minus 1 divided by mid. Here mid will be desired number of balls. That means at most that much only should be there. It can't exceed that. So as you can see here, in this case, how many operations I'm doing? 1. And 1 is not exceeding 4, which means I can check on the left side. So I will change, I will record my answer as mid, and I will change h to mid minus 1, 3. Like this, if I keep doing, I will finally get my answer as 2. So I hope you're at least able to get the flow, and how to code it now. It is very simple, but at least the flow and thought process. So what is our search space? It is about number of balls that we desire to have in the bag. And we have to check that how many operations are needed such that we can get those number of desired balls. If the number of operations exceed our max operation, we can't get that. Check on the right side. If we can get it, check on the left side of the search space, because we want to minimize our penalty, which means we want to minimize maximum number of balls in a bag. So now let us look at the code. I have coded it. It will be very easy for you to code it actually, but look at it. So we are given vector v, which represents number of balls in bag. Int op, it is number of operations maximum. So I have taken my search space. L is 1, H is the maximum element in the given input. Why am I doing this? Because obviously the number of balls in the bag can't exceed. We are not doing any operation which increases the number of balls. So it's okay to take H as this, whereas you can actually take H, higher limit, as any bigger number also. And we have to store the answer, we have made a variable answer. Now we're applying binary search and calculating mid, and we are sending something to this function called possible. We are sending the input array, mid, and number of operations. And if this function possible is possible, then we will search on the left side in order to get a reduced answer, minimized answer. Otherwise, we'll search on right side and finally we'll return our answer. But what is this possible function? This possible function, as I told you, basically it is just calculating whether the number of operations needed to get maximum number of balls in bag not greater than mid. The maximum number of operations needed should not exceed our actual maximum number of operations. Or I should say the operations needed to make number of balls in bag equal to mid should not exceed maximum operations. So that is what I'm checking over here. I am just checking that I'm keeping a variable count. Count is basically for counting the number of operations. What operation? So how many operations are needed is defined like this: number of balls minus 1 divided by desired number of balls. Here mid is desired number of balls. If count becomes greater than our number of operations, we'll return 0. It is not possible. And if the loop runs completely, we'll return 1. So this is also very important step. And basically this is what is it showing? Showing, I'll write it here. It is showing number of operations needed to make every bag have at most mid number of balls. So that is what this is showing, this much. So if you want me to run and submit, I'll show that to you. So we're getting it accepted. If you have a better solution than this, please do share it in the comment section. If you like this video, hit the like button. If you understood the explanation, then share it with your friends also. Maybe they will also understand. I just wanted to do some different kind of problems, so I made this video. Subscribe to the channel. It will really motivate me. And until the next video, take care, stay safe, keep learning, keep growing, stay tuned. Bye.